Alright, welcome back for part 2 of this solving equations using square roots. Alright, the ones we did last time, you didn't have to do this crazy part right here, which is good. So hopefully you guys do a first part of homework, and then we'll deal with the second part. Say rationalizing the denominator. I think it's going to be very, very big. First off, two things you never want. You never want a fraction underneath a radical, and you don't want a radical in the denominator. Those are two things you do not want. And by radical, I mean this thing right here. That's what we call a radical. So in order to avoid that, there's something that we need to do to rationalize these things. For example, in order to get this fraction from under the denominator, there's something that we're going to have to multiply it by, so we don't have that. So why don't we do this? In this case right here, I can multiply this by some kind of 1. Actually, let me put that up here. So, and in language that y'all probably can understand, multiply by some variation of 1. By some variation of 1, 1 equals 3/3, 2 halves, 10/10, so on and so forth. So I mean by some variation of 1. You get what I'm saying? So if I multiply this by some variation of 1, then we can get to where we need. Say if I multiply this thing right here by the square root of 3/3. Now 3/3 is just 1, and the square root of 1 is 1. So we're not changing anything, right? But if I multiply that straight across, that is the same thing as the square root of 15 over, let's say, the square root of 9, right? Which is the same thing as the square root of 15 over 3. Now what I want you guys to notice is that the value does not change. The value doesn't change because we just multiply by 1. But now we don't have a fraction inside of our square root. Same thing here is if you don't want a radical in your denominator, you can multiply by the square root of 2 over the square root of 2. So if I do that and just multiplying across, you're going to have 4 times the square root of 2 over, let's see, under the radicands, you can multiply that together, square root of 4, right? If that happens, then that means that 4 times the square root of 2 over 2, which is the same thing. Since those can cancel, this becomes a 2. 2 times the square root of 2. So now notice that I do not have a radical. I don't have a denominator at all. That actually got rid of my denominator, and it kind of just gave me what I needed. So just understand, we don't want those two things. We need those two things to happen, one of those two things. So if I guess let me give you another one, just so you guys can understand. I'll do it for you again. Typically, I like it when it's, say, something like 5 over the square root of 5. Again, we can't, and this is another example, just in case you wanted to see it again. We can't have a radical underneath our denominator. So we're going to multiply that. Notice I put a dot there. We're going to multiply that by the square root of 5 over the square root of 5, which is equal to 1. So it doesn't change anything. When I multiply that across, that's 5 times the square root of 5 equals, over the square root of 25. So this changes into 5 times the square root of 5 over 5, right? Simplified, this is just going to be square root of 5. Let me check my math, make sure I'm good. Square root of 25, 5 times the square root of, yep. Cool. So that's just pretty much square root of 5, right? So, again, you guys, it shouldn't be that bad to just multiply those across. Now, here's the thing. You're not always going to have something that simple in your denominator. Here's what I'll say. Remember when we multiplied binomials together, we just FOILed, right? When you FOILed, that was no problem, right? First, 12, outside, 8x, inside, 3x, last, 2x squared. When we FOILed, it was not a problem to do that. Here's the thing. When you're dealing with these radicals, you do the same thing. You have to understand, these things right here, the radicals, are treated like variables. And the other parts, the other numbers that you see, are treated just like that, just like numbers, right? So if we are going to FOIL this, it should not be a problem. For example, if I did my first, which is here, that's just 12, right? Outside, that's going to be, let's see, 4. Oh, you guys should know 4 times 2 times the square root of 7. The only numbers that are going to be multiplied in this case is this right here and this. The same way you would do 4 times 2x, and you would multiply just these together like this. Same way. So you have 12 on the outside. No, I want this. On the outside, you have 8 times the square root of 7. Inside, you have 3 times the square root of 7. And last, you have, let's add that. That's going to be 2 times the square root of 49. Because now we're just multiplying the radicands together. And I'm taking it that step just to show you. So now these things right here could be added together. So you have 12. Those things could be added together. That's 11 times the square root of 7. And then here, this is just going to be, for square root of 49 is 2 times 7 plus 2 times 7. So now you have 12 plus 11 times the square root of 7 plus 14. Add those things together. You have 26 plus 11 times the square root of 7. Typically the term comes first and the radical comes second, right? I'll do another one so you guys can see. Say if I wanted to multiply those two things together, I can FOIL that. First, if in fact you want to try this on your own before I do it, please go ahead and pause the video and then go ahead and deal with it. But I'll deal with it now. First, 2 times 3 and square root of 3 times square root of 3, 6 times the square root of 9, right? Outside, minus, it's 4 times square root of 3. Inside, plus 3 times the square root of 3. And last is, what, minus 2? Putting all that together. 6 times 3, that's going to be minus 1 square root of 3 minus 2. 18 minus square root of 3 minus 2. And then 16 minus the square root of 3. So again, you're not going to need all these steps. I'm just doing this just to show you where I'm getting all the math from. But typically, some of these steps are going to be able to be skipped as we go later. So now we understand when these are how we can FOIL those together. So one part that I wanted to say is talking about conjugates. Now, what a conjugate is pretty much the opposite of each other. Well, it's kind of like the signs are different. Same binomial, just the sign is different. Like, remember when we did a plus b times a minus b, you're going to get a squared minus b squared. Notice there's no ab term when we did that. Those are kind of gone. Same thing happens with radicals. With radicals, you have 4 root 5 plus 3 root 2 times 4 root 5 minus 3 root 2. The middle term is going to disappear. And what you're going to end up with, I'll show you, but I'll show you first. What you're going to end up with in this case is 4 times the square root of 5 squared minus 3 times the square root of 2 squared. You're going to end up with those two. And I'll show you straight through here. 4 times 5, 4 root 5 times 4 root 5. Again, I'll just put that. That's going to be 4 times the square root of 5 squared. Well, actually, let's multiply it out. That's going to be 16 times the square root of 25. On the outside, you're going to have minus, let's see, that's 12 square root of 10. Inside, plus 12 square root of 10. Outside, you're going to have 9 minus 9 square root of 4. Now, what's going to end up happening is these terms cancel out. With those terms canceling out, 16 times 5, well, square root of 25 is just 5, right? So that means 16 times 5 is going to be 80. And then square root of this 4, that's going to be minus, the square root of 4 is 2, so 9 times 2, 18, right? And then that means that 80 minus 18, you're just going to get, what, 62? So notice what happened. We multiply those two big numbers together. We ended up with this really small number. So that kind of shows you what happens when you multiply conjugates together. So we can actually go through some examples of conjugates, and you'll see what I'm talking about. So say, for example, your radical number is 5 root 2 plus 2 root 3. The conjugate of that would just be 5 times the square root of 2 minus 2 times the square root of 3. Here, 3 root 5 plus 5 root 3 is just going to be 3 times the square root of 5 minus 5 times the square root of 3. And then 4 minus the square root of 3, 4 plus the square root of 3. So ultimately, when we multiply those things together, you're going to end up with a number that doesn't have radicals in it. So up here, notice that we had multiplied two conjugates together, and you ended up with a very simple number. If you multiply those together, you're going to end up with a very, very simple number. So when we have to rationalize, that's actually what's going to happen. Rationalize 3 over 7 plus the square root of 2. If I rationalize that, I can get radicals out of my denominator by simply multiplying the bottom by the conjugate. But whatever I do to the bottom, just to keep the value the same, I got to do to the top. Right? So multiplying those two together, you end up with, again, you have 3 times 7 minus the square root of 2 over whatever that's going to be. That's going to be 7 squared minus the square root of 2 squared. Multiplying that out, in the top you're going to end up with 21 minus 3 times the square root of 2 over, what's that, 49 minus 2. So 21 minus 3 times the square root of 2 over 47. Right? So we have that part. Next, let me do the other parts so you can see. In this case right here, you got to multiply by, you got to rationalize. So you got to multiply the bottom by the conjugate. Conjugate of 4 plus the square root of 11 is 4 minus the square root of 11. And whatever you do to the bottom, you got to do to the top. So that means this is going to be 2 times 4 minus the square root of 11 over 4 squared minus the square root of 11 squared. If I do that, that's really 8 minus 2 times the square root of 11 over, what's that, 16 minus 11. And that's going to be 8 minus 2 root 11 over 5. So for this third one, oh, I got 3 of them. Well, that's cool. So here's the thing. For this one right here, you have 3 plus square root of 5 over 3 minus the square root of 5. If, again, I have to multiply that by, I have to multiply the bottom by the conjugate of 3 minus the square root of 5. 3 plus the square root of 5 over 3 plus the square root of 5. Now, it has to be the same because I don't want the value to change. So why don't you guys pause the video and you guys could try to solve that. Because remember, you got a FOIL. You know what the bottom is going to be. You got a FOIL. Once you FOIL it, come back and see if you get the same thing I do. Alright. In this case, hopefully you guys ended up with something that looks like this. But it can be further simplified. That's the thing we have to understand here, is that now since all of these are even, that can be crossed out, that can be crossed out, that can be crossed out. Because they're all greatest common factor is 2. That becomes 7, a 3, and a 2. So this can actually become 7 plus 3 times the square root of 5 over 2. We'll try this one more time so you guys can really see. Try this one. And pause the video, see if you can do it, and come back, see if you get the same thing that I do. Hold on, let me pause this. Alright, you guys can see what my solution was in each one of those. All again, I'm just rationalizing the denominator. That's all I'm doing. Cool, so now you have both parts. Please review this as many times as you can and try your best on the work that's assigned.